Section 4, the Analyze phase, focuses on understanding the root causes of the problem by carefully studying the data collected earlier. In this phase, we look for patterns, trends, and key factors that are affecting performance so we can clearly identify why the problem is happening. The goal is not to guess solutions yet, but to use facts and evidence to pinpoint the main causes that need to be addressed in the next phase. Chapter 4.1, Concept Development, explains how we begin creating design ideas during the Analyze phase of DMADV. The purpose of this chapter is to show how possible solutions are generated after understanding what drives performance and customer needs. It focuses on using simple and creative techniques like brainstorming, TRIZ, and mind mapping to explore different ideas, and then narrowing them down to identify design concepts that are realistic, useful, and able to meet both customer and business requirements. DMADV, a concept, is a clear, high-level idea that explains how a new product, process, or service will work without going into detailed design. It is more developed than a simple thought, but still flexible, making it easy to explain, visualize, compare, and evaluate with others. Examples include ideas like using a self-service kiosk instead of manual registration, automating claim processing with only exceptions handled by staff, offering modular product features, or using a mobile app instead of paper forms. During concept development, many such ideas are created first and then reviewed and refined in later steps. Brainstorming is a simple and effective technique used in DMADV to generate many ideas by allowing team members to share thoughts freely without criticism. It is useful because it brings together knowledge from different functions, encourages creative and out-of-the-box thinking, and captures real experiences from operations, customers, and engineers. This helps the team quickly create a wide range of possible concepts to explore further. Typical brainstorming starts by clearly defining the problem so everyone understands the goal, such as reducing claim processing time. The team then agrees on simple rules and a fixed time to keep the session focused. Ideas may first be written silently to encourage individual thinking, followed by round-robin sharing so everyone contributes. All ideas are captured visibly, then grouped into similar themes, and finally the most promising ideas are shortlisted for deeper analysis. Effective brainstorming works best when everyone avoids criticism or judgment so ideas can flow freely. The focus should be on generating many ideas first because a large quantity increases the chance of finding strong concepts. Wild or unusual ideas are encouraged since they can inspire practical solutions. Team members should build on each other's ideas using a positive mindset, and conversations should stay focused with one person speaking at a time to ensure everyone is heard. This activity starts by clearly defining the problem so everyone understands the objective, such as reducing claim processing time from 5 days to 1 day. The facilitator then explains the rules and sets a time limit to keep the session structured and focused. Team members may first write ideas silently to allow independent thinking, followed by round-robin sharing so each person has a chance to speak. All ideas are captured visibly, then grouped into common themes, and finally the most promising ideas are shortlisted for further exploration. In ABPO claims process, the problem of high turnaround time can be addressed by brainstorming different solution ideas. These may include using a customer self-service portal, automatically routing claims to the right specialist, checking documents at the time of upload, sending auto reminders for missing information, using standard communication templates, or integrating with external systems to fetch data automatically. All these ideas serve as raw concepts that can later be refined and developed into effective solutions. TRIZ is a structured method for innovation based on patterns found in millions of patents, showing how problems have been solved creatively. Instead of starting from scratch, it provides proven principles that guide idea generation. In DMADV, TRIZ is useful because it promotes systematic innovation, helps overcome mental blocks like "this can't be done," and is especially helpful when technical contradictions make solutions seem difficult. TRIZ helps solve problems by focusing on key ideas. Contradictions happen when improving one thing makes another worse, like increasing speed without losing accuracy. The 40 inventive principles provide general strategies, such as segmentation or merging, to overcome these conflicts. The ideal final result encourages imagining a perfect solution with no cost, harm, or complexity, while using resources emphasizes making the most of what already exists in the system or environment. In this service example, the problem is reducing call handling time without lowering quality. The contradiction is that increasing speed can hurt quality. TRIZ principles help solve this creatively. Segmentation splits calls into simpler parts using IVR for standard queries and humans for exceptions. Prior action captures customer data before the call to save time. And mechanics substitution replaces some human tasks with automation or chatbots. These approaches guide the creation of design concepts that address the contradiction effectively. In this manufacturing example, the challenge is creating thinner packaging to reduce cost while maintaining strength. TRIZ principles help generate solutions. Composite materials use layered structures instead of a single material. Cushioning or anti-weight designs absorb shocks, and the nested doll approach packs only delicate parts instead of the whole product. These principles guide the development of innovative and practical design concepts. Mind mapping is a visual tool that organizes ideas around a central theme, like drawing a tree of thoughts. In DMADV, it helps structure ideas from brainstorming, or TRIZ encourages connections between concepts and makes it easier to see how different design aspects relate to each other. It is especially useful for exploring concepts with cross-functional teams. To create a mind map, start by writing the main problem or goal in the center, such as new claim processing system, then draw main branches for the key aspects that affect it, like customer experience, process flow, technology or systems, data and analytics, compliance and risk, and cost or efficiency. This helps organize ideas visually and shows how different parts of the design relate to each other. Next, for each main branch, add sub-branches to detail specific ideas. For example, under customer experience, you could include self-service, real-time status updates, notifications, and simple forms. Under technology, sub-branches might be integration with CRM, OCR for reading documents, and AI for fraud detection. This expands the map and shows connections between different design elements. After adding sub-branches, continue expanding the mind map until it captures many detailed ideas for each theme. This creates a visual overview of all possible angles for concept development. For example, in a hospital registration system, the central idea might be future hospital registration with branches for channels like mobile app, kiosk, or web portal. Experience factors like wait time and ease of use. Technology like HIS integration or QR tokens. Data management, risk considerations like privacy. And operations including staff roles. From this map, ideas can be grouped into concepts such as mobile-first registration, self-service kiosks with token systems, or a hybrid of counter and digital pre-registration. After generating ideas using brainstorming, TRIZ, and mind mapping, the next step is to filter, combine, and refine them into 3 to 5 strong design concepts. A viable concept meets key customer requirements, is technically feasible, cost-effective, operationally practical, compliant and low risk, and scalable for the future. At this stage, concepts don't need full details but should pass a basic sanity check before deeper evaluation with tools like PooMatrix or QFD. The first step in identifying viable design concepts is to cluster related ideas from brainstorming, TRIZ, or mind maps into logical bundles. For example, in insurance claims, one concept could be straight-through processing with pre-validation, AI risk scoring, and auto-approval for low-risk claims. Another could be assisted self-service, where customers enter data through a portal with chatbot support and agents handle only complex cases. A third option might combine the traditional process with partial automation for document checks and routing. The next step is to do a quick qualitative screen by asking if each concept solves the key customer requirements, aligns with business strategy, has any obvious obstacles like technology or regulatory issues, and whether it uses existing capabilities or needs major changes. Concepts that clearly don't fit are removed. Then, a simple selection table can be used to score concepts on criteria such as customer impact, speed of implementation, cost, risk, innovation, and strategic alignment. Based on these ratings, the top two for concepts are shortlisted for further development. For each shortlisted concept, a one-page concept brief is prepared. This includes the concept name, the problem it addresses, key features, how it meets customer requirements, a high-level process or architecture, key assumptions, and potential risks or dependencies. These briefs serve as inputs for the next analyze and design phases, where the concepts will be evaluated in more detail and modeled for implementation. Chapter 4.1 fits into the DM-ADV flow by showing how we move from understanding the problem to generating and organizing solution ideas. In Define, we clarified the problem, scope, and CTQs. In Measure, we analyzed current performance, customer needs, and risks. In this Analyze chapter, we use brainstorming, TRIZ, and mind maps to create solution ideas, organize them into high-level design concepts, and shortlist viable options. Later in Analyze and Design, these concepts will be evaluated with tools like QFD, POO matrix, simulations, and cost-benefit analysis to select the best ones and convert them into detailed designs.